out, move into the corner, letting the filler metal flow to the outside edge, even pulling the rod out a little if necessary to maintain a uniform arc gap. Then back into the corner and across, slowing down to let the puddle flow out. Keep the upward progression tight and use a high enough amperage setting so you don't have to wait for the puddle to tie in. If you have any trouble running an uphill fillet with 7018, try starting out with a 332 diameter welding rod. The smaller puddle is easier to control. You can also try stepping in a downhill pass of 6010 or 6011 first. This not only provides good penetration, it fills in the corner, making it easier to maintain a uniform arc gap for welding uphill. For heavier metal and more weld buildup, you can either stack weld beads side by side or use a weave bead. Lap joints in any position are fairly easy to weld. The outside corner will melt away, especially on thinner metal. If the top edge isn't uniform, hold your grinder flat and skim along the edge to straighten it up. A fillet weld is also used on a T-joint, and this is very similar to a lap weld, except you don't have that outside edge heating up quickly. On a T-joint, the top side of the weld is going to require more heat, so angle the rod into the corner to push the puddle up. If the rod is not angled enough to allow that molten pool to flow out to the top, you may leave undercut. With 6010 or 6011, always bring the arc back to the leading edge to fuse the corner. Angle the rod to push the puddle up. Watch the top side to avoid undercutting. The filler rod, 6013 or better yet 7018, will provide more weld deposit. In the flat position, hold the rod nearly perpendicular to the weld, making sure the molten pool is flowing out both on the top and the bottom. Try running straight, maintaining a uniform arc gap and travel speed. If you need a bigger weld, try using a larger diameter welding rod or stacking up weld beads. Overhead is the same as flat. Hold the rod nearly perpendicular to the weld, angled to push the puddle up. Maintain a uniform arc gap and travel speed, not letting the metal or the weld deposit overheat. For more weld, stack beads from the top down. On a vertical T-joint, downhill is easier. Use a modified circular motion, always coming back to the leading edge, then pushing the puddle out to the sides. Set the amperage high enough so the puddle spreads out and travel fast enough to stay ahead of the molten filler metal. Watch both sides to avoid undercutting along the edges. 7018 uphill will build weld faster. For the first pass deep in the corner, angle the rod up slightly. Pay attention to the arc gap, following the base metals into the corner and along the sides. This is very subtle. It's just a little movement into the corner as you're coming across, but jamming the rod into the sides cools the weld down, and long arcing across the center creates more heat. Most of the problems with running uphill come from not maintaining a consistent amount of heat. When the arc gap varies, the heat varies, making it difficult to adjust the travel speed to keep the filler metal from spilling down. Try to maintain that arc gap. As soon as the puddle flows out to the side, move into the corner and across to the other side. Let the puddle flow out and move back. Set the amperage and adjust the travel speed so you don't have to wait too long on the sides. As you gain experience and physical control of the rod, you can try to carry more metal uphill. But while you're learning to weld, just get that first one deep in the corner, keeping it uniform and avoiding undercut. If you need more weld, maintaining the arc gap on the second pass is a lot easier. Depending on the amperage setting, slow down or hesitate on the sides until the puddle flows out. Move across the center a little quicker and slow down to let the puddle flow out on the other side. Then just side to side, keeping the upward progression tight. For heavier metal and more weld the direction of the weld. If you can get to both sides, alternate welding on one side, then the other until you're finished. Last is corner joints. Depending on the weld position and what you want the finished corner to look like, there are choices in preparation and fit up to provide good penetration. One piece can be beveled at a 45-degree angle, opening it up so you can get the rod all the way to the bottom. The beveled edge is going to heat up quicker than the flat. Angle the rod into the joint, making sure the puddle flows out and ties into both pieces. A first pass of 60-10 or 60-11 will provide good penetration and is easier to handle in the bottom of the joint. With 70-18, try using a 332 diameter rod for the first pass, especially in the horizontal or vertical weld position. Keep the top of the filler beads flat to avoid trapping slag and leave the top edges as guides for the cap. On thinner metal, you can tack up the pieces without a bevel, then use a grinder to groove the joint. For ornamental type projects, you can grind the weld for a nice square corner. Corners can also be fit up butting the inside edges. For maximum penetration, tack up leaving a small gap. This type of fit up requires less metal preparation, and for ornamental type work, the weld can be polished for a more rounded corner or ground flat for a beveled corner. In the horizontal position, angle the rod into the corner, fairly perpendicular to the weld, and maintain a uniform arc gap. When both pieces are the same thickness, they should heat up evenly and relatively quick. With 70-18, adjust your travel speed so the puddle flows out to the top and bottom edges, but move fast enough to keep the weld deposit from sagging. Because both edges are heating up quickly, the filler metal will be more fluid, limiting the amount of weld buildup you can handle without having it sag. If you need to make 2 passes to fill the joint, run the first one fusing the corner and out to the bottom edge. Use the second pass to fill in the top. On thicker metal, plan the weld, leaving a little of the corners for the final series of passes. In the vertical position, downhill will make a flatter weld and will probably require more than 1 pass. For vertical up with 70-18, the outside edges are going to melt fast, so try using a smaller diameter rod for better control. Pay attention to the arc gap, following the base metals into the corner and along the sides. Keep moving. You won't have to hesitate at all on the outside edges. On any type of corner joint, you want the amount of weld to equal the thickness of the metal. If you have any concerns about the strength of the joint, you can make a fillet on the inside, but this will tend to draw the pieces in the direction of the weld. Whenever possible, always try to make the outside weld first. Well, I hope I've given you an idea of how to put 2 pieces of metal together. There are many more options in metal preparation and fit-up to provide for penetration, limit the effects of the metal drawing, and reduce the amount of filler metal deposit. Regardless of the type of weld joint you're working on, you need to experiment with the amperage, rod angle, and travel speed, learning to control the amount of weld deposit and figuring out just how much metal you can carry without having it sag or drip. Make slight adjustments in the travel speed when necessary to maintain the puddle and use the rod angle to control the shape of the weld buildup. Focus on the weld puddle, watching the sides tie in and keeping the filler metal from overheating. Above all else, take your time, have fun with this, and work safely.